Alrighty, so today for our unit, right, we're going to continue our study of shapes. And now we're going to move specifically into quadrilaterals, right? So we spent like 2, maybe even like 3 units talking about triangles, right? We proved triangles congruent, and then we like did similarity, which involved a lot of stuff with triangles, and we did just a whole unit on just simply right triangles. And now we're going to jump into quadrilaterals and look more specifically at those. Hello? Hey, I'm well. You're welcome. Oh, okay. Yes, like I feel like I heard the word. Yes, yes. That's about all I can say. That's about it. Yeah. Yes. He is not. Bye. Okay. Good. Thank you. Get to the paper here just a second. Okay. Just like the 11:30. And it should be 3? 3 of them? 4 of them? 4, because we had the test, yeah. So 4. Okay, so anyway, moving back to what we were talking about here, properties of parallelograms. We've got the essential question here. What can you conclude about the sides, angles, and diagonals of a parallelogram? Okay, so the main focus here is kind of our main idea, I guess, is we want to get to the point where we can kind of like be given a shape, all right? In this case, we're talking about parallelograms today as our main focus. And we want to know, kind of like just investigate all the different properties that come with knowing that a shape is a parallelogram, right? What can we then say is going to be true, just knowing that a shape is a parallelogram? Of course, it's helpful, right, to talk about what a parallelogram is. So we know what a quadrilateral is already. A parallelogram, right, it's kind of in the word there, the idea of a parallel, right, is a quadrilateral that has 2 pairs of parallel sides. 2 pairs of parallel sides. So, you know, if we were to look at this shape right here, you know, we kind of see like 1 pair of parallel sides right there, 1 pair of parallel sides right there, I should say, and then we got these 2 as well. Okay, and so that yields then that shape. I'm not going to have us go through the constructing and stuff like that. I think I just want to kind of move into the actual properties and things. All right, just because I think it's going to take too much time. That's something maybe I should try in the future. But anyway, so we're going to, like, again, we're just going to kind of like work through some properties that we have here. So explain 1, okay, states that the conjecture that we made in Explore about opposite sides of parallelogram can be stated as a theorem. Okay, and the proof requires drawing an auxiliary line in the figure. So the theorem is if a quadrilateral is a parallelogram, then its opposite sides are congruent, right? This is not too hard, I think, to convince ourselves this is true. If you just look at the shape here, it's like AB and DC, those are opposite sides. Yeah, they look like they should be equal, right? AD and BC, opposite sides as well. Yeah, they look like they should be equal. But of course, we don't want to just assume it's true. We want to prove it's true. Okay, so let's take a look at how we're going to do that. All right, so first statement here, we're told that ABCD is a parallelogram. And of course, why do we know that's so? What's our reason for that? What's that? Given. It's given to us, right? It's told right there in the given. Okay, very good. Then we're going to draw a segment here, DB. What's another name that we have? What's this segment? What do we call that kind of segment? A what? A diagonal, right? Because it connects 2 non-consecutive vertices there. So we'll just draw a diagonal. And so, again, the reason why I can do that is through any 2 points there is exactly 1 line. Now, AB is parallel to DC, and AD is parallel to BC. How do we know that that's true? What's that? How do you know that these 2 sides are parallel and these 2 sides are parallel? We could kind of say given. Is that what you were saying, Jenny? I think given would be acceptable there. You could also say definition of parallelogram, because we're told ABCD is a parallelogram, so therefore we're going to know that. So either one, I would say given / definition of parallelogram. It depends on how you want to Number 4, we have angle ADB. So this angle right here is congruent to angle CBD. Okay, and then we have ABD is congruent to CDB. Okay, so essentially we're saying this angle, and then this angle, and this angle. They're congruent. Why might we be able to say that they're congruent? Jay? Very good. Alternate interior angles, right? We have to go way back to Unit 1, okay, and think about, well, parallel lines crossed by this transversal that we kind of drew in here creates these alternate interior angles, which we know will be congruent, okay? ABDC being parallel creates these two angles being congruent, alternate interior, but then AD and BC being parallel creates those two angles being congruent. Okay? I'm pretty sure that we did a problem just like this, okay, back when we were proving triangles were congruent, right? Didn't we see problems just like this and use that alternate interior angle stuff? So we're doing the exact same thing, but with a different end result. DB is congruent to DB. What's the reason for that? Reflexive property. All right, it's the same line, but the official one is the reflexive property, right? Remember that? Okay. And so then number 6, we're going to prove something because angle side angle triangle congruence theorem. So what are we going to state here? What goes in the statement? If our reason is a triangle congruence, then maybe we need to come up with a triangle congruence statement right here. So maybe we could say like triangle ABD, right? ABD is congruent to, now once I've named that first triangle, how must I name that second triangle? C to D to B, right? Because I want AB, so this is the long side there to then D. So I'm going to do C to D, the long side there to B, so CDB. Please be careful about how you name that, okay? It's very important there. Okay. So we're proving triangles are congruent. Then we go to this statement where it says AB is congruent to CD and AD is congruent to CB. What's a reason that we can say that that's going to be true? Yeah. What's the 5-letter abbreviation? CPCTC, you got it. Yeah, corresponding parts of congruent triangles are congruent. Exactly right. Once we prove the triangle is congruent, their corresponding parts are congruent. How do you know they're corresponding, Mr. Whitmire? AB, first 2 letters. CD, first 2 letters here. A, B, C, D, right? AD, first and third. CB, first and third. There it is. Okay? So that's it. All right. So now we have this property. If you have a quadrilateral that is a parallelogram, then its opposite sides are congruent. Okay? Turn the page. But our properties don't stop there. Okay? The conjecture from the explorer about opposite angles. Again, we didn't do the explorer, but you get the idea. How do you think opposite angles are going to be related? Well, it tells us right here. If a quadrilateral is a parallelogram, then its opposite sides, opposite angles are congruent. So angle A and angle C, those are going to be congruent, and angle D and angle B, those will be congruent as well. Okay? How are we going to prove this true? A very similar argument to what we did before, actually. Okay? Very similar argument to what we did before. Hello, thank you, Miss Baker. Okay, so ABCD is a parallelogram. Okay, so we've got that right there. How do we know that's true? Given. Okay, then it asks us to draw segment DB. Okay, so segment DB, how are we able to do it before? Through any 2 points, there's exactly 1 line. So that's kind of like our reason there. Okay, same idea. Through any 2 points, there is exactly 1 line. Okay, and then I think I'm going to give you guys a few minutes here and just try this one on your own. Okay, try this one on your own. If you need some help, you can refer back to the earlier proof there. But go ahead, take a few minutes, try and fill out the rest. I think I helped get you started there. Try to fill out the rest. Okay, try to fill out the rest there. Jenny? I'm already running. Here, I got you. else need the marker? So go ahead and try and finish up that proof, and we'll call in some folks to help us do that. Fill it in here. Just a moment. Two pairs of alternate interior angles here because there are two that are agreed. So ADB. So AD is using this angle is equal to then what is that? CBD. C. Very good. And I think I have another pair of alternate interiors. Exactly right. Yep. Thank you, Grace. All right, so let's go to Chrissy for number 3 there, Chrissy. Exactly right. Yeah, same as before. Given or definition of parallelogram. Okay, good. All right, how about Brandon? Brandon, were you able to come up with some alternate interior angles that were going to have to be congruent based off of this kind of information?
Angle ADB is congruent to angle CBD, and angle CDA is congruent to angle ABD.
Looks good. Well done. Yes, you got both pairs there. Okay. Nice thing was it's very similar to, again, the one we did last, or just a few minutes ago, right? But that's it. That's it. Very good. Good job. Okay. And then how about Jenny? Jenny, we're able to come up with number 5. What's our reflexive property here? Yep, DB is congruent to itself. No surprises there. Okay. And then Jake, how about number 6 there? Angle side, angle, triangle congruence. So what are our 2 congruent triangles then we can say? ABD. And sorry, what was the other one? CDB. And like this proof is like identical almost to the last one, but here's the major difference, right? So Avery, what's our final statement here then?
Angle A is congruent to angle C.
You got it. And then what's the reason? CPCTC. Okay? So using the exact same idea, creating 2 congruent triangles, we can also say, therefore, that the opposite angles A and C are congruent. Now notice what we did not prove here. What we did not prove was that B and D were congruent. Okay, but you'll see here again the note. We kind of glossed over this. A similar proof will show that angle B is congruent to angle D. What major thing would we need to change in the way we kind of set this up? What major thing would we need to change in the way that we set this up in order to show that B and D are congruent? What's like the major thing we'd have to switch? Press it. Change the diagonal. Instead of going from D to B, it would have to go from what? A to C. Same principle though would apply. We'd have alternate interior angles. We'd have reflexive property use. And then it would create that other scenario that we want. Okay? So property number 2 of parallelograms, okay, that you need to understand. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay? last property, yes, the last property that for which you'll be responsible for about parallelograms, okay, is that the diagonals bisect each other. The diagonals bisect each other. So if a quadrilateral is a parallelogram, if you kind of draw both diagonals will cut each other in half. Okay? Diagonals bisect one another. Okay? And so we'll look through this proof here. We'll do this one together because it's a flowchart proof. We haven't done a whole lot of these, okay? But they kind of follow in a similar way to the step proofs. You can kind of just follow them this way, okay? The statements go in the bubbles. The reasons are just below the bubbles, okay? But in this case, you can kind of see, you get a better idea of what statements lead into what other statements, and then how you can then sometimes combine multiple statements together to get a single result, right? So it's maybe a little bit easier to see, you know, some of the logic that's going on here. Either way, what's going to go in this little gray bubble right here for the given? Yeah, ABCD is the parallelogram, exactly right. Okay. Let's see here. What about this one? The definition of a parallelogram. What does the definition of a parallelogram tell us about a parallelogram? What is a parallelogram by definition? By definition, what makes a parallelogram a parallelogram? Avery?
If opposite sides are parallel.
Yeah, opposite sides are parallel. So in this specific instance, right, what are the opposite sides? It's kind of already marked there, I guess, isn't it? But what are we going to say? AB, we parallel to what? DC, yeah. AB, parallel to DC. And what else? DA. Exactly right. Very good. DA, parallel to CB. Okay, very good. So we got to kind of squeeze both of those in there. Okay. All right. So you also want to have this right here. Opposite sides of a parallelogram are congruent. Okay. So we can hit both sides here if we want to. So let's just say AD is congruent to BC. But also we could say that AB is congruent to DC. Kind of went out of the room there. Okay. Now we have a lot of alternate interior angles here that we could indicate. So what we're going to focus on, let's focus on here, we kind of have two pairs of triangles that we could prove congruent. You see here, we're going to end up proving triangles congruent. We have two pairs of triangles we could do that with. We could do that with here, this kind of like bow tie, right, shape, AED, BEC. We could also prove AEB and DEC congruent, all right? So let's just pick one of those pairs, and I think, let's see here, I think the book does ABE and CDE. So they use this top one and this bottom one right here. So we're going to prove these two triangles are congruent. Okay? So what are alternate interior angles that are in those triangles? Okay, how would we name those? Well, we have BAC, and what will angle BAC be congruent to? Angle what? So BAC, that's this angle right here. What will that be congruent to? Yeah, DCA or ACD. ACD or DCA, this angle right here. Mm-hmm. Okay. CDB, this angle right here, what will that be congruent to? ABD, yeah, very good. Angle ABD. Okay. And we said, if you remember, so that right there. And we said those are congruent and those are congruent. So you can see the angle, side angle right there. And so we'll name our two triangles here. Triangle AEB, I guess I'll say. AEB is congruent to triangle CED. So you can see why we spent so much time, right, trying to prove triangles congruent here. It's very powerful, very useful here, especially with like the quadrilaterals and the parallelograms, right, getting these properties. Once we've done that, well, we have our last step here. So what are we trying to prove? AE is congruent to CE. And BE is congruent to DE. Okay. And there it is. There's the proof. So again, you can kind of appreciate a little bit more of the logical flow here when you see these flow proofs, right? You have the given. From the given, we kind of like divide into two different directions. One direction, we kind of use the definition of the parallelogram to come up with congruent angles. But then one other direction, we use the parallelogram to use one of the properties that opposite sides are congruent. And then by coming up with these two angles and this pair of sides, we put all three of those together to come up with the angle-side angle for the two triangles being congruent. And then that results in CPCTC as well, okay, directly following from that. Okay? So it's kind of like the logical flow. All right. Questions on any of that? Ms. Avery.
I had a question on the example 2 one.
Oh, okay.
In order to prove angle B and angle D congruent, could we also like use the same diagonal and then use like the angle addition thing?
Yes, I would say exactly right. You could. That is another option there. Absolutely. So we could use angle addition here. Yes, since we could say that like something like angle ABC is equal to ABD and CBD, and then say that but those two angles are equal to these two, which those two together add up to make ADC. So yeah, we could avoid having to do that. Yeah, that would be an alternative strategy there. Good thinking. I didn't think about that one, but that would work. Okay, very good. So now that we've proved these things to be true, all right, now we're going to use them. All right, now we're going to use them. Okay, we've proved them to be true. Now we're going to use them. So how? Right? So you can use the properties of parallelograms to find unknown lengths or angle measures in a figure. Right? Classic kind of example here. So we've got some information given to us in the diagram. We're told that ABCD is a parallelogram. Once we know that, we have those three properties. Well, I guess really four, right? By the definition of the parallelogram, by definition, opposite sides are parallel, right? Property, opposite sides are congruent. Property, opposite angles are congruent. Property, diagonals bisect each other, okay? So if we want to find, for example, the length of AD, which is right here, what can we relate AD with? BC, right. Okay, so 7x equals 5x plus 19. You solve the equation, you get x equals 9.5. Is 9.5 our answer? No, because we're trying to find the length of AD. We just know x. So you got to plug 9.5 in for x. 7 times x, 66.5. That is the length of AD right there. Okay, let's find angle B. All right, angle B is 6y plus 5 degrees. What can we relate that with? Six y plus 5, whoops. 6y plus 5 has to equal what? Yeah, angle D, 8y minus 17. Okay, so we'll add the 17 over, subtract the 6 over. So we're going to get, what, 22 equals 2y. So y is 11. Is that our final answer? No, we have to plug it back in. 6 times 11 plus 5, 66 plus 5, 71 degrees. Okay. Number 7 asks, suppose you wanted to find the measures of the other angles of parallelogram ABCD. Okay, so we know angle B is 71 degrees, and therefore angle D must be what? 71 degrees as well. How can we go about finding the measure of angle A and angle C? We don't know anything, we don't have any expressions there. We don't have an x to plug into. But what could we do? What could we do there? Okay, keep in mind, this is a parallelogram. what could we do to find those other missing angles? All right, Avery, you got an idea?
Yeah, there are like 2 ways that I thought of.
Okay, 2 different ways. All right, well, hit us with one.
The first one is that they're going to be co-interior. So.
Okay, but let's pause right there. Let's think about that. So we have parallel lines crossed by a transversal here. These 2 angles are co-sharing, right, the same side, or the same side interior between. So go ahead, proceed there, Avery. So then how will these 2 angles be related?
They're going to be supplementary.
Supplementary, right? So this angle will be the supplement of 71 degrees. So in our case, 109. Okay. So I'll pause right there, Avery. I want to see. So anyone have a different idea about how we could do this? Well, what do we know about angle A and angle C? They're going to have to be what? Equal, right? And there's 2 of them. What do all the angles in a parallelogram have to add up to?
360.
360. So what can we do here, Preston?
We'll add the 271s up, then subtract from 360.
Okay, so take the 71s, 2 of them, subtract them from 360. You're going to get a number. That number's not 109, though. What do you do? Divide by 2. Exactly right. Okay, if we take 360, subtract off these 2 angles, we're left with what the sum of A and C have to be. Since A and C are going to be equal, the shape's a parallelogram, we can then divide by 2. That gives us the 109. Very good. Very good, Preston. Okay. And is that what you're going to say, Avery, for your second?
Yeah.
Okay. Thanks for letting me, get someone else to try that one. No, I appreciate that. Okay. Okay, so let's try another one here. All right, now number 8 and 9, you'll see some other things. What is drawn in our parallelogram here? Or what are drawn? Diagonals. What do we know about the diagonals of a parallelogram? They what? They bisect each other. That means they cut each other into 2 equal parts. So you guys go ahead, set up and solve for 8 and 9. I think you've got enough there to do it. So go ahead, set up and solve for 8 and 9. Okay, set up and solve for 8 and 9. Find both of those pieces. Find both of those pieces. All right. Find both of those pieces. Find both of those missing pieces. QR. Cursive or just like this? I just like to do it. I hate cursive so much. When I was in elementary school, I couldn't wait till I could do it. Just did it. All right. let's go to Daniel. Daniel's son, number 8. How did you set this up here to solve for QR?
So I set it up with 3z minus 4 equals 2z plus 4.
Okay, yep. Again, we know that PQRS is a parallelogram. Therefore, opposite sides must be congruent. Okay, so we solve here. We get z equals 8, and so the answer is 8?
No.
No. What's the actual answer?
The answer is
20,
20.
yeah. QR equals 3 times 8 minus 4, which is 20. Okay, very good. Good job there, Daniel. Let's go to, someone we haven't heard from yet, maybe. Someone new. Anna! Anna, how about number 9? What'd you do there?
We did x plus 9 equals 4x minus 6.
Okay, great. And let's see, we get 3x equals 15. So x is 5. And then what'd you get for your length of PR?
We got the whole thing.
Right, because we want to find PR, right? So,
I looked at part of it.
so what would it be?
Like for 1/2, I got 14, so it must be like 14 times 2.
Which is?
Wait, hold on.
Next time.
28.
28, you got it. Very good. Okay. Sorry, I didn't mean to put you on the spot, but you got it, so no problem. So 5 plus 9 is 14. 5 times 4 is 20. Minus 6 is another 14. Of course, we know the diagonals bisect, so like Anna said, we can just multiply one of those parts by 2. 14 times 2 is the 28 there. Yeah, be careful. It was asking for PR, so good catch. Good catch there, Anna. Okay. All right. So, number 10. What do you need to know first in order to apply any of the theorems in this lesson? What must be true? Eli. That the shape is a parallelogram, right? Crucial, right? And just because it looks like a parallelogram, you don't want to assume it is, right? You want to have either it given to you, that fact, okay, or it just depicted by the markings, okay? So, okay, and then number 11, actually like us to talk about this one here. So in parallelogram ABCD, point P lies on segment DC here, as shown in the figure. Explain why it must be the case that DC is twice AD. Use what you know about base angles of an isosceles triangle. Okay. So why will DC be twice AD here? So, any ideas there about what we can say? For sure. Remember that this thing's a parallelogram, which means that AB and DC are parallel. AD and BC are parallel there. Aubrey?
Did you say that because since AD and AP are like congruent and P lies in like it's like the middle?
Okay.
So if you have AD, that's the same length as AP.
So let's pause right there. So how are you determining that AD and AP are the same length?
Well, I mean, I was just kind of assuming.
You looked at it and you're like, these must be congruent. Okay, so you're on the right track there. This triangle is going to be an isosceles triangle, but we want to be careful about which sides are in fact going to be the congruent sides here. Let me help you out just a little bit here, Aubrey. I think let me help you with this. So we've got AB is parallel to DC, right?
Yeah.
We have this transversal right here. So if this angle here is x degrees, what does that mean this angle right here has to be? X degrees as well. Okay, like that. So that means it's not that AD and AP are congruent. What's congruent instead? So again, it's not AD and AP. These are, so maybe if I turn the shape this way, right? There's our isosceles triangle right there. The two base angles are congruent.
So those
So
Like alternate interior.
these, yeah, alternate interior, those were alternate interior angles. So then what two sides of this triangle right here are going to be congruent? If these two angles are congruent, right, then what two sides must be
I don't
congruent?
know.
All right, it's the opposite sides. So this one and that one right there, okay? And then we have another isosceles triangle over here, do we not? Right here. Again, parallel lines crossed by a transversal. So if that's y degrees, this is going to be y degrees right here. And so then we have these two sides are also congruent. Okay. So DC, which is equal to DP plus PC. Right? DC is equal to DP plus PC. But what do we know DP is equal to? DA. Actually, I don't need to put that symbol because we're doing measures. What is PC the same as? BC. So these two added together would also equal DC. But what's true about DA and BC? So they're parallel, and it's in a parallelogram. They're opposite sides. That must be they must be what? Congruent or the same. So we can say then that BC is equal to DA, and then DA plus DA, da. 2 da. And there it is. DC equals 2AD, DC equals to DA, or AD there. That was fun, right? No, Mr. Whitmire, stop torturing us. All right. You asked for it, I guess, and I'll stop. So, starting on page 426. Page 426. I'd like you to do numbers 3, 4, and 5, but only pick one. You need only do one of those. Okay, you need only do one. And let's see here. I don't know. I'll have you do like. Have you do like number 7 as well. 7 through 9, I guess I'll say. 7 through 9. That one's all. And then 17 to 21. Number 24. I think that's all I'll torture you with. Okay, so 3, 4, and 5, all 3 of those are proofs. You may pick whichever one you want, okay, to do one of those. Please do follow the formatting that it has. So I think like number 3, for example, is a flow proof. Please do complete it as a flow proof, right? 4, you can complete as a 2-column, I think, and then I think 5 is also 2-column.